Camera window. Dang. Okay. Hopefully it's getting my audio. That's the part I'm a little worried about. So these are the Romeo and Juliet problems. And my Romeo and Juliet problems, I use them as a teaching technique, but they're a little different than what actually happens in Shakespeare's play. Yes, this is the scene where Romeo is outside of Juliet's balcony, and he is somehow professing his love for her. So here he stands on the lawn below, and there's Juliet. You can tell by the little princess hat, and she's in her second floor balcony, which, because this is a castle, the first floor is much taller than the rest of the floors. She's 7 meters, or about 23 feet above where Romeo is. Now, in my version of this story, Romeo has lost his voice. He has a little bit of laryngitis, and so he has taken a roughly baseball-sized rock, and he has written a love note and wrapped it around the rock and tied it with some string, and he needs to throw it with some initial velocity up to Juliet. Now, he does not want to hit Juliet with this rock. That would have the negative consequences of her not being necessarily receptive to the contents of the note. He wants the rock to just stop when it gets to Juliet's altitude and she can reach out and grab it. Okay, so he doesn't want to throw it so slowly that it doesn't even get to her. That might not look good. And he doesn't want to throw it so rapidly that it either hits her or goes past her at a high rate of speed. He wants it just to stop when it gets to the top. Now, the one thing that's missing from my drawing, and I'm almost done with part 1 of the 5-step problem solving method, but I have not indicated my coordinate system. So I'd like to just go over here and say that 0 is going to be where the rock starts, and the positive direction is going to be upwards. Now that is step 1, all done. So it's time for step 2. Step 2. Is the list of knowns and unknowns. And they're always roughly the same. Because we've always agreed to have the starting position of the object be at the origin, this X right here is the final position of the object up at the top. This is going to be 7 meters. Lucas says I can't see anything. Is anyone else having that trouble? Okay, I don't know, Lucas. Maybe you can reboot or something. You should be seeing a window. Maybe you got a window that's buried or something. Okay, here we go. The starting velocity is not known to us. Romeo's going to have to throw it with some starting velocity, but I don't know what it's going to be. But the final velocity is 0 meters per second, because up here at the top, we want the rock to stop. Now, acceleration doesn't seem to be on this picture anywhere, but we have to think about the situation. He throws the rock, it rises into the air, and it slows. Why does it slow? Because of gravity. So the acceleration is going to be the acceleration due to gravity. But in this case, it needs to be a negative 9.8 meters per second squared. Negative because gravity always pulls downwards, and I've chosen upwards to be positive. The time is also not known to me, so I've filled in my list of unknowns, and I've got 2 items that I don't know what they are. And that's going to help me with step 3. Step 3 is to choose an equation. Now, because we don't know the time and we're not looking for the time, we're going to avoid having the time in our equation. We need an equation that has VI in it, but does not have T as well. And that's this equation right here. This is what I was calling the no T equation. If you look on your list from your notes, or if you made yourself a little note card with these equations on it, that might be kind of a cool thing to do. But that's the equation, and I write it down once in its natural form so that I can get credit for choosing the correct equation. Whatever the case, I'll make this video available, so if you missed something, you can catch up. We're going to put this information in. VF is 0, and that has to be squared. VI is unknown, so we'll leave it as VI, and that has to be squared. And then we have 2 times negative 9.8 times 7. Look, folks, I understand if you don't want to square zero here, but you need to be in the habit of always putting these things in the these things that are in the equation, putting them on the next line, at least until you do the operation. Because if you start dropping things off willy-nilly, you might make a mistake. Speaking as someone who has made a ton of silly, stupid mistakes over the course of his lifetime, and I'm just talking algebra here, I just go in a plotting way. So now I am actually going to square zero, and I'm actually going to multiply this out. And this turns out to be minus 137.2. Negative because of this negative sign, and 2 times 9.8 times 7. I did it on my calculator earlier. It's 137.2. Now the next step is probably to get this negative thing onto the other side. I can think of adding 137.2 to both sides. And that'll leave me in this situation, which isn't bad, except I have to take a square root. And I'll get that VI is 11.0. How can I not remember what the square root of 137.2 is? 11.7. Now I've done everything, including putting the units on the answer. I've done all 5 steps with one exception, and that is, does this answer make sense? Is it possible for a human being to throw a rock into the air at 11.7 meters per second? I'm going to wait until somebody has an opinion about that and tells me.
No.
Okay, I didn't even see who said that, but let me ask you the follow-up question. Why do you think that this is hard to do or impossible to do?
Well, I already did part of the lab last night,
Yeah?
and just by rolling it, I don't think I could ever get that much force per second. Maybe a couple of seconds, but definitely not a second.
So 11.7 meters every second. 11.7 meters is like 11 yards, like 12, 13 yards. Do you think that a human being could throw a rock 13 yards in 1 second? And I think a human being can. And the reason why? Baseball. Now, a human being probably can't run 11.7 meters per second. We would not expect someone on a football field to run more than 10 or 12 yards in a second. But in a game of baseball, the entire game is predicated on the idea that you can throw a ball faster than somebody can run. You see, if the batter hits the ball and it just drops onto home plate, the catcher can pick it up and throw the person out at first base easily because they can throw the ball faster than they can run. The fastest people run at about 10 meters per second. So here's some numbers for you to kind of carry around for fun. Walking speed is anywhere from 1 to 2 meters per second. 1 is for that really slow mosey, and 2 is for a strider. Running speed, like the fastest runners, is 10 meters per second. And freeway speed is 30 meters per second. So if this had been about 30 meters per second, I would agree with you that there's no way that Romeo can throw it at 65 miles an hour. It takes a lot of skill to throw that fast. I think the starting pitcher for our...
I have a question.
Go for it.
I get how they could do that in baseball, but they're not throwing it straight up in the air.
Yeah.
They're throwing it straight up in the air,
You're
directly against gravity.
right. And you know, that is interesting. It probably is harder to throw something straight up in the air than it is horizontally. And just keep in mind that this is an initial velocity. That yes, indeed, he throws it with this speed to start with, but immediately it slows down and then eventually stops. So this is just the starting velocity. And I think it's a reasonable starting velocity. It's going to be a good chuck on Romeo's part, but it is going to be possible. I would just
I
get...
think Romeo got a real arm.
If he's got an arm, yeah. Well,
Okay, that makes more sense. Thank you.
no problem. You know what we might do? We might propose an experiment. I happen to have a Hot Wheels radar gun. Don't laugh. It's supposed to be used on Hot Wheels, but it also works on real objects. And I could get some batteries for that thing. We could loan it to somebody. They could lay on the ground, and someone could stand over them and throw a ball up in the air as fast as they can. We can see if they could get to 11 meters per second. But I think it's just reasonable. What I'm trying to teach you here is to compare your answers to stuff you might know. And Velocities are a little harder to think about than distances, and accelerations are even harder to think about. So anyway, so save this. This is important, but we're not done with the problem yet. This is the first example, first step. But now, Juliet.
Mr. Robin, what was that very last one? V, then something with an F?
Yeah, freeway speed is about 30 meters a second. I think my Y got a little.
Thank you.
There we go. Okay, so in the second part of the problem, Juliet reads the contents of the letter, and she is not happy. Perhaps Romeo said something untoward. Perhaps he just made a lot of spelling and grammar errors, and she decided she's not interested in somebody like that. So she decides to throw the rock back down to Romeo at 10 meters per second. She's not really aggressively trying to hurt him, but it might actually happen because we want to know what is the final speed of the rock when it gets down there, and how much time does it take to get down there? How much time does Romeo have to get out of the way? Keep in mind, it's still the same 7 meters back down from Juliet to Romeo. And, of course, we have to put our coordinate system. So I'm going to choose 0 to be up here where the rock starts, and I'm going to choose positive to be the downwards direction. I'm choosing positive to be downwards. I know that offends some people, but the entire problem is happening down here, so why not make all these numbers positive numbers? They're a little easier to work with. If that offends you, go ahead and make positive upwards. All the numbers in your problem will be negative numbers, and you will get the exact same answer I get. All the negative signs will cancel each other out. It's amazing. It's bitching about physics. Here's the list of knowns and unknowns for this guy, and we can go a little faster this time because we've done it before. But the distance down is 7 meters in the positive direction. The starting velocity is 10 meters per second in the positive direction. The final velocity we're looking for, the acceleration is positive 9.8 meters per second squared this time, and the time we're looking for. Now, if we solve for the final velocity first, we'll need to avoid time, and we already know that that's this equation right here. So let's pop these numbers in. VF squared equals 10 squared plus 2 times 9.8 times 7. 9.8 meters per second squared is always squared. It's always in the units of meters per second squared. The 9.8 is not being squared in the equation, however. So slightly different things. VF squared equals 100. That's what 10 squared is. Plus 137.2. That's what these numbers are multiplied together. No minus sign this time. So VF squared equals 237.2. So VF equals the square root of 237.2, and VF equals 15.4 meters per second. So despite the fact that Juliet was maybe not intending to injure Romeo, it certainly is getting to the point where she could injure Romeo with this rock. 15.4 is a little more than half of freeway speed, so we're talking about 35 miles an hour. I think if someone hit you in the head with a rock going 35 miles per hour, you might suffer some sort of concussion or what have you. That brings us to the next part, and the next part is where we're going to try to solve for time. Now, you can use any of the other equations other than this one. This one won't help you find time because time's not in here. But I'm going to go ahead and use the Swiss Army because the Swiss Army does not rely on the final velocity that I just calculated. Also, if I use the Swiss Army, I wind up with a little bit of a sticky problem in math that I want to show you how to address. So putting in the numbers, 7 equals 10 times t plus 1/2 of 9.8 times t squared. So 7 equals 10t plus 4.9 t squared. And we got a little bit of a problem here. Anybody identify what the problem is? Yeah, the word it's not, the word isn't binomial. It's quadratic. This is a quadratic equation, and that means it has a variable squared and the variable in the same thing. And to solve these, what you need to do is you need to organize them so they're all stuff equals 0. So we should rewrite this as 4.9t squared plus 10t minus 7 equals 0. And once you do that, the thing in front of the squared is called a. The thing in front of the non-squared is called b, and anything else is called c, and you put that into a particular formula, and it solves it. Now, a lot of calculators have the formula built in, and if you use Desmos or Wolfram Alpha, it'll do it for you. I just happen to have it memorized, so I know that it's minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now, when you get done doing this thing under the square root, you find out that that is 15.4. It's the same as what we did here. It's this thing. It's kind of interesting, over 9.8. And at this point, we cannot use the minus sign. 10 minus 15.4 would be negative 25. And even if we divide that by 9.8, it's still going to be a negative number. What would a negative time mean? Well, it would mean that the rock would hit Romeo before Juliet throws it. And that makes no physical sense, all right? Not unless you're in some sort of strange, bizarre, backwards time, Christopher Nolan movie kind of thing. So we're going to have to use the plus sign here, which means that minus 10 plus 15.4 is going to give us 5.4, and that's going to be divided by 9.8, so the time winds up being 0.55 seconds. Now that's where things get a little dicey. That rock is going to make it from Juliet's hand to Romeo's vicinity in just over half a second. Romeo has a half a second to recognize what's happening and to move out of the way. I don't know if any kind of dodgeball skills or ninja skills can help you do that. I think that's a little short on the time, so I certainly hope that Juliet did not aim at Romeo's noggin, and then we don't have to explore the EMT situation back in ancient Verona or wherever Romeo and Juliet took place. It was Verona, wasn't it? I don't know. Shakespeare.
It was Verona.
Awesome. Okay, so save these numbers because we're going to come back to them in a month. We're going to get these same numbers using a totally different physics technique.